Here's an example of balancing chemical equation. So we see that this is a reaction between aluminum hydrochloric acid and it forms aluminum chloride and hydrogen gas. So what we need to do here in order to balance, we need to take into account all the elements, and we need to make sure that the elements on the reactant side it should be equal to the elements on the product side. So we have reactants on this side, they are the reactants. I'm going to write down R for reactants. Reactants are present before the start of reaction, and then we have product on the right side of the reaction, and they are produced as a result of chemical reactions. So we're going to take into account how many atoms for each element are present on the reactant and product side. So we have aluminum, hydrogen, and chlorine, and we are going to take into account the number of atoms for each on both the reactant and product side. So how many aluminum and how many hydrogen and chlorine are present on both sides of the reaction. So in order to balance the chemical reaction, we want to make sure that the number of atoms for each element must be equal on both sides of the reaction. So let's see, in order to look for number of atoms, we see a number down here. So there's nothing, it's always assumed to be as 1. There's 1 atom for aluminum on the reactant side. Then hydrogen, there's nothing down here, so it means it has 1 hydrogen atom. And same with chlorine, it has 1 hydrogen, 1 chlorine atom. And then we have aluminum on the side, 1. There's nothing down here, 1 atom for aluminum. And then 3 for chlorine, and then 2 for hydrogen. So we are going to start balancing with the complex formula first. So we see that the number of atoms for aluminum are equal. Hydrogen, it's 1 here, 2 here. Chlorine and hydrogen both are unequal. So what should we multiply 3 with? So we get to balance chlorine. What should be the multiple of 3 in order to we could get a balanced equation? So we multiply 3 with 2. That means we use this number to be placed in the front. So remember, whenever we place a number in the front, it changes the number of atoms present inside. So we have to recount everything. 1 times 2. We do 1 times 2. Aluminum have become 2. We do chlorine 3 times 2. So we use 2 to balance. It would be 6 chlorine atoms now. And then we have 2 hydrogen. Now this 2 will not affect hydrogen because it's been separated by a plus sign. Now that we have to make sure that we balance the aluminum on the reactant side as well. So we place a 2 here. Our aluminum have become 2 now. Okay, in order to balance, we have 6 chlorine. So what do we do to balance? We are going to place a number. We are going to place 6 here. So it's 1 times, it's going to change the number of atoms for hydrogen as well. So 1 times 6 is 6 hydrogen. And 1 times 6, 6 chlorine. And here, so same thing, now that we have the number of atoms for chlorine equal, aluminum is equal, we need to balance hydrogen as well. So we can place a number 3 here. So what should we multiply 2 with? So we get 6, that's going to be 3. So after multiplying 2 by 3, we have 6 hydrogen atoms. So we can see here aluminum is 2 on the reactant side, 2 on the product side, hydrogen 6 on the reactant and 6 on the product. And then we have chlorine 6 on the reactant side as well as 6 on the product side. And this balances our equation. And this is an example of a balanced chemical equation.